Yeah, good afternoon. As we have postponed our class for afternoon session, we'll back with our class. In our last class, as I told you that we are discussing on a TCL script, and we have discussed on procedures or a function. So how to define a user-defined procedure in a TCL script, we have seen, and how you can send an argument means arguments there, and how you can define a parameters for a procedure. Everything I have told you. So before calling a function, a procedure or a function should be defined within a keyword proc. So that is a one thing which we have discussed in a last class. Now coming to the next thing, that is what about a list in a TCL script. So coming to the list, I will share the window. I'll share, right? Yeah, back here. Yeah. Now, see here how a list will be defined in TCL script. You can see here, list is nothing but an array. So now here, a list is declared using a list built-in function. Like that also you can do, or directly you can do. If you want to define through a list, here set a list, you have to tell 1 2 3 4. So that is for a 1 2 3 4 it will be assigned. If you doesn't want to use the same thing, you can define like this, set a within flower braces 1 2 3 4. So this is a usual way which we are going to define this particular means elements for an array. So retrieving an element with an index, that always we are going to do with L index. So index is 0 based, so that is it will just like C. So always array index will start from an 0 to the n minus 1 elements. So that you have to keep in your mind. So then set B, you can define each value, that is L index value. So list index value, L index means list index. So list index value you can define always, that is list index $A3. So B as a value 4. Now observe carefully what this particular thing will be there here. So L index $A3, B as a value 4. Now what is this 3 here? L index, whatever this the L index is there, indicates this particular index value. Now 1 2 3 4, the fourth value of an array A is 4, right? So the fourth value will be copied, the 4 will be copied to B. Then $A end, again 4 will be copied. $B is 0, you know that the 0th value, first value 1 will be copied to B. Like this, we are going to define an L index for each and every position of the elements in a list. Coming to the next thing, that is now here see how you can concatenate the two lists together. Now you can see here the concatenation of two things can be done with, means two lists can be done with let B, set B within square brackets. You observe here CONCAT, that is concat. Concat is a command. So in that, again within a square brackets, list 1 2 3 4. Again within a square brackets, list 5 6 on it. First it will comes to here, it will create a list 5 6 7. Next it will comes here, it will create a list 1 2 3 4. Then afterwards it will comes to the outer brackets here, that is concat 1 2 3 4 with 5 6 7. So 1 2 3 4 5 6 7 will be a list elements which will be set to the variable B. So in this way you can set that particular thing. Now, how you can append a value to the list? So that is one another thing. Now observe here, this is a particular command where instruction which you can observe here, set A list 1 2 1 2 3, means 3 elements is there. Now L append A 4. Now A will be added with 4. Now observe here, L append. Append is a append, you can see that. What do you mean by append here? The means element will be added at the end of the list. So that is called as an append. L append means list append. That's it. List index, list append, like that we are going to use. So L append A means we are telling which array, which list it is. So 4. 4 is an value. Like a sorry, like a set command. Now coming to the next thing, to find a length of the particular list, that is L length. So we have to give a list there, or if you give a there means within that, if you give a there, then it will be told 4. Or here directly they have given a list here 1 2 3, then it will tell 3 elements. If it doesn't give anything, if you give only list, it will tell 0. Like this, you can define a list and you can add elements, means L append, and you can find even a length of the list. Coming to the next thing, that is looping over the list for each. This is important for you. For NS2, for each is very much important. Why? Because we are using that particular concept in many things. Now you observe the function here, proc print list, input list, means whatever array is there that you are sending here, and for each element means dollar input list, for each element dollar input list. So what you are going to do, put as the dollar element. What do you mean by this? You take one by one value from the input list and you display that particular value until the end of the input list. The one by one value will be taken and that will be displayed one by one. So here element takes on a value of each of the members of the list and it will be displayed. So for each element is the one which is very much important here. So that you have to know always. So for each element, whatever is there in a list, that we will take into the consideration. Sorry, and we can handle one by one. Here just we are displaying it, but you can do n number of manipulations on that particular element, add, or you can delete, or you can do something else with that particular element. It depends on your problem or an operation. Coming to the next thing, now write a procedure to reverse list that reverses a given list and returns the reversed list. Now we'll do this particular program as our list programs. Later on we'll shift to the array concepts, really how a arrays will be defined in a TCL. Now how to do this particular means how to do this particular program here, we'll go as usual with an Fedora and we'll consider one particular list and we'll define one particular function and we'll try to reverse that particular list of the elements. How to display the reverse elements, that we have to think. Okay. Now we'll start with this particular program. As usual, program is there here. I think because of the time consistency, you can take this particular program itself. Note down this particular program. Just I will explain here only. You can see here proc reverse list, very the function which is there here. You can see here input means we are sending a list here. You will define one list. How to define a list? Set a within square brackets list 1 2 3 4. Just that's the thing. Now a will become a list. Now you send a with reverse list. A reverse list. How it should display? 4 3 2 1. That's it. Now observe here what we are going to do. Set length. So set length. Length will become a very length list. Okay. L length input. L length input. That is there. L length input. What do you mean by this? Whatever the length of this particular array is there, that will be copied to the length. Now set output as a list. This is an empty list which we are going to create as a output list. Now observe carefully. For we are using for loop. For set I to 1, $I should be less than or equal to the length of that particular length, what you are going to define, that length list, increment I one by one. Now, L append output. So you are going to append that particular means element, means output list, which is empty here. You are going to append that. Before that, what you are going to do here? Observe carefully here. L index of the dollar input, L index of the dollar input, you are going to take, and you which position you are going to take? You are going to take a position as expr dollar length minus of dollar I, dollar length minus of dollar I. First you n elements, 4 means 4, 1 2 3 4, 4 elements is there. 4 minus 1 is 3. At a third position, the element means whatever means that whatever a third position, the element will be whatever a length element, the third position value, what is it? That is 1 2 3 4. 0 1 2 3 4. That 0 1 2 3. So values are 1 2 3 4. Now 4 will be taken and it will be stored in a L, this one. So again, you are going to do the same thing. It means until you are going to comes with the length element. So again, length you are going to check, means I will be incremented by 1, 2, 2 is less than or equal to 4. It's true. Then you will come here. Then again, L append output, L index input, whatever is there, 2 is there now. 4 minus 2 is 2. Now at a second positioned element of input list you are going to take and you store here. So like that, reversely you are taking the element, means from last to first you will take one by one element of an input list and you will store in a output list. So in this way you are generating the list here. Finally, you are returning that particular output list. So in this way you can reverse the list elements, which will be a simple program which you can see there. Coming to the next thing. So that is all arrays in a TCL are one dimensional and associative called hash in other lists. Now, what is the difference between list and arrays here? That is a very much important thing which you should know. A list is a one where it's an heterogeneous. So anything you can put in that here also, we will call that as associative. But there, whatever you are, if you want to append and all, means L append you have to use, L index you have to use to identify the index and all. So that is a one disadvantage which is there in a list. But in arrays, it's not like that. As usual, your C arrays, you can you can manipulate that particular arrays here. Now you can see here set M my array of 0, means within brackets 0. If I give 0 index, value is 1, 1 index 2, then second index 3. That is what is the value of a my array. If I display my array, it will give 1 2 3. Or a particular position also I can display here. L index is not needed. So this brackets will indicate that particular. The ordinary brackets will indicate that particular thing. So this is important here. So there's a difference which you have to catch here. So here no L index is needed to define a particular array index. So directly by giving within brackets, you giving a integer number, a single number, that will be acted as an index automatically, like a C programming. Now coming to the next thing. Now you can see how you can use this. Not only numbers you have to use. This is a specialty in a TCL script. Here the keys which you can use, the index keys which you can use, that can be associative also. What do you mean by this? You observe here, set address that Sunil, some city name. Okay, then set address Dan, Berkeley, Praveen, San Jose. Now if I tell put as dollar address of Sunil, means indexed Sunil, automatically it should go and it should display the Cupertino. So in this way, you can define not only the numbers, but in a C program, according to the C program rules, always the index should be an integer, and you should define with 0, 1, 2, 3, 4 only. But in TCL script, you can use this keys also. That way, we'll call it as an associated array also. That you can keep in your mind. Coming to the next thing, so how the two things you can define here, see the difference I'll tell you very clearly. Set my array 0 1. So what do you mean by this? The zeroth index of my array will be 1. Set my array, again observe carefully, both are same variables. My array chocolate, index key here is a chocolate, then chip, that is the value will be a chip here. Now observe carefully. Set key list. Just I want a key list within a brackets array names my array. Array names my array. So key list will be 0 and a chocolate. So the key, whatever key lists or key indexes of my array is 0 and a chocolate. There's no rule like that. You have to use always numeric values like that. Here mix you can use. Now observe this for each key. This is very much important. What I told you, how for each is very much important. In a last session I have told you, right? For each key is a variable here. So within array you can see array names my array. So what you are going to do, set value $my array of $key. That is whatever a key is there, you are taking here. Means here first you will take 0, then you are going to take chocolate. So there you can set a values for that particular key. Now $key and $value might be used for any action necessary. So wherever you want, you can use this particular type of an arrays. So in this way, you can deal with an arrays in a TCL scripting. Now regular expressions is there. This is not so important for NS2. Don't worry about this. Now embedding and extending TCL also. Embedding of C program is like for embedded systems which we are going to use. OTCL is important now. Now OTCL, what actually OTCL? Object-oriented TCL scripting. What is this? Tool command language? That is, you can define an object for a class which is there outside or which has been defined a path from this TCL program to another C++ program. That means OTCL knows the concepts of hoops here. Now you see, object-oriented TCL. Interpreted similar to the TCL, same instruction by instruction it will take, but as objects and classes. So it always deals with objects and classes. Bit difficult compared with an object-oriented scripts, but usage in NS helps you to understand better. That is network simulator. Now, the parser and a command procedure do exact here. Means whatever the TCL script it will do, parser means it will take entire sentence, it will split into the parts, correct. So same thing here also it will do, but observe here, class is a special command that create the object class with some standard methods on them. So here, whenever you are defining a class or a new class like that, you are going to create an object for that. Unlike C++, here we write multiple definitions. So not only single definitions you can use here, you can define a multiple definitions for a class. So each method definition adds a method to a class. Each instance variable definition, what is there with set or whatever the thing you're using, adds an instance variable to an object. So this is important here. This is a multiple definitions you can create to the C++ programs. In TCL, I will create one particular method. Okay, I'll write method. That method in that instant to that particular C++ program using an object of that particular. The next thing, create a player class. Now take an instance. Now this is there. Actually, to say here in NS2 and all, we are not creating a classes and all. Why? Because already existing classes will be there. For that, we are creating an objects. So here these procedures and all, when it is needed, I will tell you. So when you are creating your own algorithm and you want to insert into the network simulator for a evaluation, at that particular moment, this class and objects definition procedures are very much important. You should create your own procedure of a OTCL to connect to your C++ programs, which you have did. That we'll call it as an patching. So in this is a one thing which will be done. So in this way he'll do this. So this is a final thing. Coming to the next thing, how OTCL and TCL linkage will be there in a NS, that we are going to deal with. Before this, we'll deal with what is a network simulator, why you need that network simulator, and why the network experiments will be always simulated, why not a practical experiments will be done. So that we will discuss now with this particular upcoming session. Now I'll stop this sharing. Yes, and we'll back now here, right? So I'll go back with again another PPT, right? Yeah. Now back here. Now I'll share again that PPT. Share this. Yeah, now we'll deal with a network simulator. We'll start with an introduction first. So network simulator. Why network simulator? Question always arises. And what is simulator? The question always arises. For example, I'll tell you one thing. Assume that no simulators are there for a network and you want to do your own experiments manually. For a sake, I'm going to tell you. As a network designer or a scientist, I'll create one routing algorithm. Now I want to check that routing algorithm in a realistic environment. So where a bulk of devices and routers will be there and a huge topology will be there. Assume a huge topology of some 500 systems. Now if I want to evaluate my algorithm there in 500 systems with router, everything there, I'm well confident on that algorithm and I want to evaluate. But for a manual implementation, imagine the cost of what that 500 or 200 to 500 systems with the routers, connections, establishing a network, everything. Assume that I will implement my algorithm and I will start running that particular, means evaluating that particular network. Assume my algorithm will fail. If my algorithm fails, then what I can do with all these systems and routers, everything. There is this huge amount where we, for experiments, where we should bring. So this a problem arises. Because of this particular thing, we'll go with a virtual representation of a network. That we'll call it as a simulator. Coming to the next word, that is a simulator. There is a two types of simulators here. I should tell you that the static simulator will be there, and as well as the dynamic simulators, or and another type is discrete event-driven simulators will be there. What do you mean by static simulator? I will tell you like this. Now, I want to build one particular building, or I want to build one particular car, everything. Okay, building you want to build. I will make a prototype. I think you have seen, many of you have seen that a small toy like toys, means dolls like structure can be created of any buildings and it can be represented. How they will do that? Whatever the meters, square meters of the dimension of building will be there, they will reduce to the millimeters or centimeters. The small objects of that particular window and walls and dome, everything they will do, and they will make a structure of that, and they will represent that particular structure as a model of that particular building. So this is called, this is static here. That is once some 10 square meters is there, you're going to reduce to 10 centimeters or millimeters. So there's a one way of the simulation thing which you can be taken into the consider. Like this, many models you can create of a car or any aircraft. So then you know this in a real world. So you can create, and first you can analyze what paint you can apply for that, what is the interior, what's the exterior. Today you can see all those particular things. Coming to the next thing, that is the dynamic simulators. So how, for example, assume where we are going to use this dynamic simulators and all, especially in a chemical reactions. Before doing a practically, first we'll simulate that chemical reaction, and we'll see virtually. Why? Because it's very important. Observe when you want to see any nuclear or neuron explosions or emulations and all. If you want to evaluate, it's a huge thing. Assume some chemicals you want to combine. If practically, if you do it, it will become a poisonous gas, and some dangerous things can be happen. So because of that particular thing, a compounds, whatever atoms, compounds, whatever will be there taken, and it will be simulated, and there the things will be taken into the consideration. That is one type of a simulation. Especially in a networks, we are going to use discrete event simulators. What do you mean by this? See, simulator is thing like this. We are creating an object, or we are creating an entity in a simulator that is equivalent, having all the characteristics of your real-time device. So that you have to keep in your mind. For example, here I am creating one particular node. Assume the characteristics of whatever a device up to the network layer, whatever the your device will act in a real time, same thing will be there here also to this particular node. Like this is important, otherwise we can't evaluate, or you can't evaluate the performance of that particular any of an experiment. Even your modules, if you consider, if you want to study that particular modules and all, the module should have the same characteristics of a real time. So that's the one thing here. Discrete event, what is this is discrete means unknown events. For example, I will ask you one particular question. At this particular circle, when traffic jam will occur? Can anybody tell? No, it's really a difficult thing. So when traffic jam will occur, expecting that, so that is not means it's not in the hands of the any person. So based on input of an vehicles from all the four roads or other roads, depends on heavy vehicles input, the traffic jam will occur. So when it will occur, we have to see, watch and see. We have to wait for that. Like that, in a networks, what happens when packet will drop? No one will expect. When congestion will occur, no one will expect. So whenever it has been occurred, you should catch that. So that is called as discrete event. When event occurs, it will takes that into the consideration. That simulator will takes that into the consideration. What is this event? For example, assume I'm teaching you here in an online class. So whatever is there, assume one real example I'll tell you. When two friends will be there, when the one person will beat another person, can you tell anybody? No. No, no. We can't tell like that. Why you will beat? No. Maybe you will beat. You can't tell 100% no. If you tell no, in an instant you will beat him. Right? So this is an event occurring. Means suddenly it will occur. So that type of things will always be there in a network. That is when congestion will occur, when packet will drop, who will come and interfere, who will snatch our packets, means who will take out our packets. So all this particular things, if you want to evaluate, if you want to find a throughput and all based on that, and if you want to find a what is a delay time, where retransmission will become more, delay will become more. So like this, everything will be affected this particular. To study this particular thing, we are going for a network simulator. Now I think you have understood why network simulator NS2 lab is there for you. You are studying a computer network subject where you are studying a different routing protocols, different devices, everything you are studying. And now some realistical examples connecting two or three systems to your LAN, connecting, then what will be the throughput, then how the traffic will be, there if this much bandwidth is there and all that we are going to evaluate in this particular simulator. Now coming to the table of contents. Now your table of contents is what is the NS2, what is good for, basic component, simplified view of NS2. Example is there, topology, movement scenario and the traffic scenario, NS script, OTCL linkage, how it will be done, trace file. What is the NAM? We are going to discuss getting the NS2 program and installations. So in this way, we are going to study this part. First, we'll go with the introduction. Network simulator is the one which has been designed with a project name WINT. So WINT project, that's virtual internet test bed, like that it has been first taken into the consideration. A collaborative simulation platform has been designed by AT&T, UC Berkeley University and a Xerox company. Now observe what I told you, this event driven simulator. Your network simulator is a event driven simulator. Particularly, I'll tell you like that. If packet drop, you catch that particular timing when a packet will drop. I will tell my simulator like that. Why? Because I want to know that how many packets will drop from this time of my propagation to this time of my simulation. So how many packets will drop from when moving from source to destination? I want to know that. Assume this is one problem. So this is the event driven. Assume what will be the average throughput if I send these 1,000 packets from a source to the receiver destination. All 1,000 packets will receive or not. All 1,000 packets will move in same time. So everything, if I want to evaluate, that is also based on a event driven. Now the simulation will be done always on a packet level, not application level. That is, almost all NS2 is a good simulator to evaluate until the transport layer and this one means network layer. So IP protocol and your TCP and UDP protocols can be evaluated more than an application protocol. Everything will be here, means whatever data will be treated as an packet. So everything, whatever I'm moving from one place to another place in a simulation, that unit will be treated as a packet. Both this network simulator will support wired and wireless network. Another one important thing is it's a free software and it will support object-oriented structure. Means everything will be treated as an object and a class. Now, what is it good for? That you should know always. See, in a different companies today and next coming companies and all, always there will be research centers in a companies that how fast our performance you can make, especially network based companies. That is how fast we can improve the transmission of the data from one place to another place to evaluate or to test the performance of existing network protocol. So how existing network protocol it's working, whether it's working correctly or not. To evaluate that, NS2 is good. To develop or to prototype a new network protocol and evaluate the protocol. I want to design my own protocol and I will design that own protocol and I want to evaluate that protocol. 100% it's good. And you can do that once it is your performance is correct and you can propose a new protocol to the world. So this thing will also, that means you can imagine what is the role of NS2 in a network research especially. Then a large scale or a virtual environment simulations not possible in a real experiments. I have given an example of this to you. So large experiments you can't do in real time, you can do using a NS2. Coming to the architecture of your NS2, very simple. See here, come over here. NS main source code in a C++, it will be there always. This is the NS. Once if you install, you will have an NS 2.3 version, something like that. One folder will be there. In that folder, all subfolders C++ programs will be there. Very clear. So this is a one C++ programs which will be interacted with a OTC. Now you can see here, OTCL, TCL is a program which you are going to do. Means you are writing that particular program. and here TCL-CL is there. What is this TCL-CL? TCL-CL is a one which will connect the OTCL TCL program of you to the C++ of a NS and vice versa. That is, it's an a bridge TCL-CL. It's an interpreter and a converter between OTCL and an NS, which is there in a C++. Now, network simulation animator will also be there. What is this animator? Means finally, after simulation, everything has been over. Either you want to show your output in a form of animation, or you want to show in a textual form. At that moment of time, a NAM is another one tool which will be there in a NS. So that will be used. OTCL, TCL, user command interface will be there. What is this TCL-CL? NS OTCL interface. The interface between OTCL, TCL and NS C++ programs is called as that one. In depth of an architecture, now if you design, see, always the TCL program will have two parts in a network. One is the movement scenario and another one is the traffic scenario. What is a movement scenario? What is a movement scenario? I will tell you like this. This node is to be connected to which node? What will be the link between these two nodes? What will be the bandwidth? And how much time it will need to reach from this node to that node. So like this, a movement scenario, a topology first you have to create. After creating a topology, means one structure you have created, assume with several nodes. Which will be the source node, which will be the destination node you have to identify, and you have to tell what traffic you have to move from source node to the destination. That will be done in a traffic scenario. Including both, you will have a TCL script. OTCL script will be there, which is running. So this TCL interpreter, what it will do, it will connect that to your NS program C++, whatever you have installed. What the C++ programs usually will have, everyone will have that doubt. That will have these components. Event scheduler will be there. Network components will be there, network environment setup will be there, everything, all these components will be there. One by one component you can use according to your network. What components you want, you can take that components, you can initialize in your TCL programs, and you can call that particular C++ programs in your TCL, and that TCL-CL will be connected to that. Then you can evaluate that. And two types of output will be there always in NS2. Note down, this is very much important. I'm very clearly telling you. So this is very much important. Why? Because always two outputs will be there. One is a NAM animator. That is .NAM file you can generate. What is this .NAM file? .NAM file is an input file to the NAM animator. That is, I did so and so simulation. For example, I will tell you like this, out of some 10 nodes, one node will be a source and another node will be a destination. Through this 10 nodes, I am passing a packets from one node to the another node. Now this scenario, you want to show your friends as output. So that is called as that simulation, whatever is that will be recorded in animation type. That is called as .NAM. That is network animation mode. So using this NAM animator, you can run that. And usually you can see the nodes, how packets is moving from one node to another node, color of a packets, everything you can define. So that's a one thing, means just for to show that animation of the packets from source to destination in a topology. Coming to the next output, this is a very important output, as if you know. That is that whatever a simulation you are told, means you recorded something, how many packets dropped, you catch everything, that will be recorded in a trace file. So and so time, so and so, this is a so and so time which has been there, and this is the time the packet has been dropped. This is a source and this is a destination. When moving from this source to this destination, at this particular time, packet has been dropped, one line of information. Like this, 1,000 together lines of information will be there, which we'll call it as a out.tr file, that is trace file. Now, what for this trace file? To evaluate, to check the performance of this taking the data from that, putting a filters or AWK program, writing a AWK program or grep commands like that we will put, and we'll extract our needed information, and we'll generate a different graphs for that, and we'll compare the performances with one network with another network. So this is another one very important output file which will be there in NS2. So as a designers are evaluating ourselves, TR file is very much important. To show the simulation to others, NAM will be there. So I think everyone followed this particular architecture of an NS2. If you understand this particular architecture, then developing a NS2 programs using a TCL script will be very much easy for you. Now we'll take one example of a topology, and we'll see how we can build a program using an NS2. Now coming to the first thing you can see here, assume this is a problem which they have given. How many nodes will be there? 4 nodes will be there, starting from 0th to 3rd node. And there will be rules like this: 0 to 2nd node, there will be a connection of bandwidth 2 Mbps, 10 milliseconds it should be there. Problem they have given 1 to 2, 2 Mbps of 10 milliseconds of delay from 1 to 2, it must be there. And 2 to 3, 1.7 Mbps bandwidth must be there, delay must be 20 seconds. What should be the packet size? The means moving a packet size, it should be 500 bytes. So this is a problem they have given. Assume now you want to design a topology for this. Then how will you write a program for this TCL program? How you are going to write for this particular topology? For that, you can see here, this is a program which you can write. First, always first, what you have to do, you have to create a nodes. First, you have to create a nodes. How many number of nodes are there in a problem? There are 4 nodes. Starting with N0, I'll start up to N3. Observe carefully. So set command and all I have told you, assignment command. So within square brackets, this will be executed first. $ns node. What is this $ns? $ns is your simulator environment or an object first you have defined here. So first you have to define that. To define that, you can see here later on. Create a simulator. First, create a simulator object. Now this is overall your NS program. Assume first you have to create that. How you are going to create? Observe carefully. Set NS within square brackets new capital letter S simulator. Capital letter S simulator, you can ask me, this is a C++ file name which will be there in your NS library. So same name you have to call here. For that class, you are creating a new object. Observe new, you know why in a C++ new. For an instant objects or a dynamic object creation, you are going to use a new, correct? No. So like that, now NS is an object for this particular simulator. Now it's not a variable, it's an object which has been set for this particular class. Now here afterwards, your entire simulation will be under this particular NS. Right? Now we'll go back. Observe here. Now NS, you got it, why NS, right? So that is set NS within square brackets new capital letter S simulator. So for this capital letter S simulator, as I told you that it's a class file which will be there in a NS library. Now back here. So after that, what you have to do? You have to create a moment scenario. How you are going to create a moment scenario? According to the topology problem, what they have asked you, like that you have to create. First, create nodes. That is 4 nodes. How to create a node? Within square brackets $ns. In my simulator, node is a command to create a node. After creating a node, copy that characteristics of node to this particular N0, N1, N2, N3. How many nodes are there? That many. Okay, nodes are ready. All 4 nodes are ready. According to the topology, I should establish a link between the nodes. How you are going to create a links? You are going to create a links like this. Observe here, $ns in my simulator ns. Why? Because for a simulator I created an object called ns. $ns in my simulation. That's a $ns only you have to keep in your mind. That is in that object. Duplex link. You can create which type of link you want. Simplex link, duplex link, or off link you can create. Both the ways. That is, duplex link means both way communication will be there. So you're going to create a duplex link. This is the keywords. You can't change this. If you miss hyphen, it's a error. Keep in your mind. So duplex link, where to where you want to create. $ns in simulator ns. I want a duplex link from $node n0. That is, you n0 only if you tell it will become a character n and 0. But $n0 means node it will become. Why? Because you defined here. $n0 to $n2. You have to create a duplex link in NS simulator with the bandwidth of 2 MB. M is capital. If you give small letter, it is wrong. So 2 MB of a bandwidth, 10 milliseconds. M and S are small letters. 10 milliseconds, and with the Q type between that 0 and 2. What Q type you need at a 2? That is drop tile Q. D is capital, T is capital. This is a class which is already existing. This class is already existing. If you give small letters, that class will not be there. It will tell you an error, right? So this is also important here. So in this way, you are going to create a links. Once the movement scenario has been over, then we'll go for a traffic scenario. So that traffic scenario and all we'll discuss in a next class, that is on tomorrow 10:50. We'll go with a new class, and in that class I will tell you how to do the lab program. We'll go directly to the lab program, and I will tell you how to do a lab program using NSG, that is Network Simulator and Graphical Interface. It will create automatically TCL script. No need to type one line each and every line. This time, because of this crucial thing you are using, let me use that particular NSG software also. I will tell you how to do that in a next coming class. Now I'll stop this sharing. Yeah, thank you very much. Thank you very much. And I think,
Thank you, sir.
yeah, this video is recorded. It will be uploaded in a YouTube channel also. And another one important message I want to tell you. Still now, all the 4 programs of part A, what you have written, I told you either you have to write in a record or you have to write in sheets of papers, not a problem. Whatever written programs is there, you scan that programs and you send all the 4 programs scanned copy to me, either in a WhatsApp or through a mail. So within another 2 days, you send all that 4 programs of part A, C programs. Meanwhile, we'll start this NS program 1. First program I will do. Later on, I will shift to theory. Why? Because second internal is coming on 17th, I think. Second internal is there. Because of that, I want to complete the 3rd unit. Almost all we are at the last stage of 3rd unit. Almost all we have discussed routing, everything, BGP, and all we have discussed. So we'll go with that and we'll complete that particular 3rd module. Later on, we'll go to the 4th module after the second internals. Meanwhile, I will try to complete the 4th module also. Any doubts is there in this, you can ask me. I think everyone written programs. Written lab programs 1 to 4. Written. Listening. I've told you no. I've told you no. Now, if you're not written, you start writing the programs. Tell your friends also. You have to submit the lab programs, written copy of lab programs part A 1 to 4. I'll put in WhatsApp also. Within tomorrow is Wednesday, Thursday, right? So tomorrow 10:50 class will be there. Again, I will take a class. Thank you very much. Thank you. Thank you.
Thank you,
Thank you,
sir.
sir.
Oh, thank you.